Thank you, JJ, for that introduction. And good morning, ladies and gentlemen. Thank you to the Southern African Institute of Mining and Metallurgy for the opportunity for me to speak at this Digitalisation in Mining Conference 2018. I'm also the Technical Program Chairman of the SAIMM Program Committee. And just want to say that from all the presentations we've seen this morning, really good quality of presentations, very strategic, and I'm actually very, very excited. My topic is, does the mining industry have defined digital strategies, or are we sitting in a sweet shop of digital solutions? If I was the CEO of a mining company right now, I think I'd be a little bit scared. There's a lot of pressure around digitalization. Every vendor is busy punting some digital solution. A lot of instances, it's the same solution, just with a 4.0. And really the question is, do we have a clear strategy and prioritized implementation plan for this vision of mining 4.0, and what does it actually look like? Now, I do think that potentially we're sitting with the risk of being on a hype curve. This is the Gartner hype curve. And even in the last couple of months, in my discussions with executives in the mining industry, there's questions starting to be answered about what is the real value of a lot of these digital solutions that have been invested in. A year ago, there was still a lot of hype, but now I'm a little bit concerned that potentially we are at the peak of a hype curve. A lot of promise, and the digital revolution is not a silver bullet for the mining industry if it's not applied in a proper, focused manner. Now, at the moment, I think we are spoiled for choice. There are a lot of solutions that are being pushed on the mining industry from vendors. Here's a little bit of a framework that we've developed at SIMINE, and the bottom axis is what we call operational systems capability. On the y-axis is performance. The red curve is really an S-curve of the mining industry's performance based on its current infrastructure, its current installed capital base. And if you have a look at that, there's another green curve which really pushes up to this mining 4.0. And I think a lot of solutions that are being pushed onto the industry span between some of them being just substitution of manual processes to actual enhancement and operational processes. And then some of them are transformational, which is looking at an overall new business model. Now, there's a reality right now. The mining industry needs to make money. And if you have a look at it, I think the mining industry is probably performing generally at the bottom of the current red S-curve there. So there's a lot of opportunity, even in the short term, to maximize profitability and to really get to the maximum performance of what I'd call mining 2.0 and generate returns. And yes, there is a transformation strategy, but we need to understand how does all fit together and what is the roadmap to value creation. So whether it's called digitalization, I know it's been overly used by a lot of different people. Is there a danger that the digital solutions may not meet expectations in terms of ROI? I have an opinion on that, but you all might have your own opinions on whether we're going to generate value from these digital solutions. Now, we can learn from other industries. I've spent quite a lot of time looking at other industries to find out what they've been doing. If you watched a keynote that I did at the MPES International Conference, you'll see there I show that the automotive industry is showing a few 100% improvement in productivity over the last sort of 12 to 13 years, where the mining industry is actually showing a massive reduction in productivity. The worst was in Australia, where productivity dropped 55%, South Africa 38%, and the US 28%. So there's a lot of stuff we can learn from other industries. I think one of the key things that I've learned is this concept of systems thinking. And having done a lot of research into systems thinking, I think it's probably the fundamental missing piece of the puzzle that's needed to be able to generate value from our digital solutions. And I'll go through a little bit of a case study, an example of how we're achieving this. Now, mining is a complex system of interconnected activities. So if you have a look at it, there's interconnected activities, which in themselves has dynamics because they're connected. You've got operational planning. You've then got the right resources allocated to the right activities. And then above that, you've got an organization that needs to make decisions. So that organization needs levels of work. It needs KPIs. It needs work and management routines. And really the question is, what does this mining system of the future look like? And how do we set up the organization that it can effectively manage that? And we need a focused and a strategy and focus to be able to achieve that. Now, the integrated mining system would probably need 4 components. You need to have a mining system, which is, what does the mining system look like? Now, irrespective of what mining system it is, we need to know what that system looks like, whether it's conventional mining, open pit, whether it's underground tabular hard rock mining. We need to understand that system. We then need this sort of IoT or technical architecture to support the data we require and the acquisition of data for effective decision making. We then need the organizational roles and responsibilities for what this mine of the future may look like, or even the current mining operation. Who's responsible for what, and how's their performance measured, that we are not all looking backwards. And then work and management routines. Who does what? How does it integrate together? And those 4 components are critical to the mining system. I'm just going to do a little bit of a advertising punt here. The co-director of the Mandela Precinct sitting in the audience, Navin, and there's a great public-private partnership between government and industry, which is called the Mandela Mining Precinct, which is driving innovation and R&D and research in the mining industry for the mine of the future, and in fact to try and enhance current operations. There's also an new organization that's called MEMSA, Mining Equipment Manufacturers Association of South Africa, and that is really trying to bring a cluster of equipment manufacturers in South Africa together to take a lot of the research, commercialize it, and drive change into the mining industry. We've also built a experiential center there called SIMINE, which I will elaborate on in the next couple of slides. So we've built SIMINE. It is a purpose-built experiential simulation center inside the Mandela Mining Precinct. There's a couple of pictures of it. It's a physical facility. And importantly, we want to make the mine of the future more tangible. That is not a PowerPoint presentation, but there's a physical mine of the future testbed. So we have SIMINE, which is a physical mining simulation of all the interconnected activities of mining. And then we want to build awareness that the mining industry needs to understand what we call operational systems capability. It's really systems thinking. And then do a lot of accelerated development around building the necessary skills to run a mining operation. And I'll show you a case study shortly. Design the levels of work and management routines, and the performance measures of the mining organization system. We also got Mindshare, which is a collaborative environment for us to share ideas and collaborate more broadly, because we need the industry to collaborate more and learn and transfer knowledge globally. And then obviously a test bed for the mine of the future. I want an executive to be able to walk in and we can show them, here is the mine of the future. Here's the roles and responsibilities to manage that effectively. Here's the data systems, and here's how you can use data effectively to make decisions. And it's not about more data, more IoT. It's around understanding what are the critical decisions you require. And it's not complicated. And in fact, I think the answer isn't IoT with lots more data. The challenge is, let's understand what decisions we need to make and what data we need to support that, because you'll find we actually don't need as much data as we all believe. So we've basically put 3 things together into the SIMINE simulation center. We've got the physical simulation. We've also built a digital replica of that simulation with STEC Mining. And that's really a full simulation that represents reality and allows us now to run scenarios to demonstrate how you can do scenario planning, an effective simulation of the mining activities, and then you can test it on a physical mine. And then we're busy partnering with companies to put the technology stack in for the mine of the future, which will involve PLCs for data acquisition and storage, a digital control room that will demonstrate what will and won't work from a data overload perspective, and then all the MOM and MES stuff. So we're trying to find best of breed to assemble there in terms of the technology stack. So where do we start then? Because now we sit with this mining industry, we've got the digital revolution. Fundamental starting point that I recommend to everyone is we need to understand your mining system, and they're all different. We need to understand that system of interconnected activities so that we can then test initiatives against that system, because until you understand your system, you don't know how to prioritize what initiatives to do. I was doing some work in Australia recently where these PhDs had done some phenomenal work on mill control, and they were then complaining that the client wasn't happy. And the reason the client wasn't happy is that even though it generated 20% more improvement on mill throughput because of fancy digital control, the mill wasn't the constraint of that system and therefore generated no value. So we need to really understand the system, and then we can focus initiatives on that from a short-term perspective to make it more viable, and also test our future-orientated scenarios against our mining system of the future. So to do that, you need a digital twin. That's the only way to do it. Mining is a set of complex interconnected activities that impact each other in terms of all the consequential, or what I call starving and choking delays between them, the variability in performance, the variability in the ore. So you need a dynamic model. It can't be done in Excel. There's only one way to do it, and that is proper discrete event simulation. And really, what is a digital twin? It's a flight simulator for mining. We should be able to test a mine plan prior to when we actually execute it, so we can see whether it's viable and what resources we need to execute on the plan. And I'm not going to go into detail on this slide because that's not the purpose of this presentation, but really it must contain every aspect of the business to represent reality. So it models the underlying activities. It must have the CAD drawings in some instances of some of those activities with the operating model, and the techno-economics above that as well. And I can go into more detail if anyone wants more information. They're more than welcome to give me a call. So the second thing that's required is we need to build systems capability in the mining industry. We've now run our SIMINE mining simulation globally with executives, management teams, business improvement specialists. I've been doing this for 5 years, MBA students, and the conclusions are always the same, that we have a low level of maturity or understanding of systems thinking in the mining industry and how it can impact performance. And I'm going to go through a case study quickly to demonstrate that. So here we have the SIMINE mining simulation. It represents an open cast operation, but I mean the principles around interconnected activities is the same. In fact, it's agnostic to business if you think about it. So we've got drilling, blasting, loading, hauling, run of mine, processing, product delivery, and a customer. We have a full management team then that would come in and run that operation, right from the GM, right down to middle management, down to actual operators. Importantly, SIMINE is not about teaching technical skill. It's not trying to teach mining skill. It's trying to teach us how we can effectively run a system. So we have 30 delegates, and they come in and they run the 20-minute game, and we see how they perform. And here's a quick case study that I'll go through. So they come in, and this again is our little curve. We have a red curve there, which is the actual SIMINE's performance of the current installed SIMINE. Now we've determined what that SIMINE red curve looks like because we have also built a digital twin. So we're able to test all the initiatives, and we're able to calculate what the maximum performance of SIMINE is if you manage it properly. So they run round one, and the team generate 12 orders. That's orders of delivery to the customer of product. So, I mean, it could be seen as ounces or kilograms, but in this instance, it's 12 units of production. Interestingly, when they give feedback to the CEO of the company after they've run round one of SIMINE, they all believe, they don't know what the red curve looks like. They believe they've done well. Everyone has worked really hard. The loading people have worked hard, drilling and blasting. Everyone has worked really, really hard. But as a collective system, it only generated 12 orders, and they think they did better. So we say to them, you have not done very well. You've lost money. You haven't made profit. Can you fix it? And they go away. We engineers, we management, we are business improvement people. They go away and they do what we do well in the mining industry, and that is lots of initiatives to do lots of stuff that costs a lot of money in terms of capital. We want bigger loaders in the pits. We want more trucks. We want screening to be improved. We want to move things closer together to reduce cycle time. So they go away and they come up with a long list of stuff that they want to do together with the capital and OPEX to implement it. And they present it back to us. We approve everything because we want to give them opportunity to improve SIMINE, we approve it all, they then go and implement it, and they run around too. And yes, they do better because they have spent money across the whole value chain. So in some areas, they have improved some activities that do impact the overall system performance, but they will only do about 20 units of production out of the system or orders. And that, in fact, the financial performance of the business is even worse than round one, because now they've spent all this capital and yet they've only got a small incremental improvement. So in reality, and this is what we then tell them, is you need to do 34 with no capital just to break even. And did you know that this system, if you understand it properly and you manage it effectively, and you understand where the constraints are and the impact of variabilities, this system can actually do 66. So we can do almost 6 times the throughput, and that's without any capital. And that's the dissonance that we need to give the awareness that, wait a minute, here we are spending capital, we're doing a lot of stuff, and we actually don't know how to effectively manage the system, what to focus on. And this is before we even look at transformation. Now you can imagine if we do transformation, these systems thinking or operational systems capability, maturity is still going to be lacking in the mining industry, even in that transformed business. So that's when we start, and we've got a whole program of different accelerated programs that we do with our clients, whether it's because what's important here, you can't go and train a whole bunch of business improvement guys and send them back into operations who understand systems thinking, because they will make no difference. Because in reality, the GM has got his priorities, the engineering manager's got his, and for somebody to come and say, well, now we need to do the following, it generally won't work. So what's important here is we're building the overall organization's operational systems capability. It starts at the CEO. The CEO needs to understand the language and he needs to understand what are the critical things he needs to effectively manage his operation, and then work down. So the CEO program is just one day of how to manage a system. And then right at the bottom level, you've got to have key people who understand the tool set of systems thinking. So that's in our SIMINE Center. We do that over a 2-week period. And fundamentals around understanding flow, the impact of variability in flow, system constraints, root cause analysis, how to build a digital twin, management levers, levels of work, all the fundamental things. At the end of that 2-week period, they will, in fact, even after week 1, they will then go back and run the SIMINE game again. And they will generally get about 62 units of production out of the same system with no capital expenditure, because now they understand a proper framework of how you go about taking a value system or value stream, optimizing and generating maximum production. Now, importantly, what are we trying to achieve here? If you have an organization and you're developing its operational systems capability in the overall organization, we don't need external consulting teams to go now and find initiatives. That organization needs to be able to define its own incremental value creation on that roadmap of operational systems capability. Clear things about what are the roles and responsibilities, supporting KPIs, what are their work and management routines, what data do we actually need to make effective decision making. It doesn't mean we need lots and lots of control room data and lots of charts. We need just a few fundamental pieces of paper, pieces of information per role to effectively make decisions. Operational planning, what data is required, asset maintenance strategy that supports, and I could talk for an hour just on the asset maintenance strategy and how that forms part of the system. And now every single piece of equipment needs a different asset maintenance strategy depending on how the system works, together with the underlying technologies and all that type of thing. So in summary, the most important thing to start with before you spend any money on digital is understand your system, understand your system dynamics, understand what are the key things in that system that are impacting that system's performance to maximize its value, and then you focus on that system component that adds value. So thank you very much for listening to my presentation. You're more than welcome to make contact with myself or Harry Sinko, my fellow colleague. As you can see, we're very passionate about this. and we really want to drive a quantum change in the mining industry. Thank you very much.